Okay. Okay, so we discussed the derivative of functions. Okay, so we have a function like f of x, and we use the symbol f prime of x for the derivative. Okay. So the most basic functions that we learn their derivatives are powers of x, like x to the power n. So f of x is equal to x to the power n. N is an integer. It could be even negative. So f prime of x is n times x to the power n minus 1. Right? So for example, if you have x squared, the derivative is 2x. If you have x, what is its derivative? 1. If you have 1 over x, that means x to the power negative 1, its derivative would be
negative x to the negative 2.
Yeah, that is 1 minus 1 over x squared, right? So here just some quick table for some examples. So these are some examples. Very simple examples. Here is f, here is f prime. And we also learned that if you have a constant function, for example, f of x equal to 1. So here, n is 0, right? X to the power 0 is 1. What is its derivative? What is the derivative of the, is 0. The derivative of constant function is 0. So if f is x, the derivative is 1. If f is x cubed, for instance, then you have 3x squared. If f is 1 over x, that is x to the power minus 1, as you said, is minus 1 over x squared, right? These are just some examples. Or root x. Here, n can be even a rational number, like 1/2. So x to the power 1/2, the derivative is 1/2 times x to the power minus 1/2, which is basically equal to 1 over 2 root x. Okay, so I would recommend to use this table or to create a table for yourself, to make a table of this elementary functions. So you should know, if I ask you what is the derivative of, for example, square root x, you should know by heart very quickly. It's 1 over 2 root x. Okay, that's the first step. And these are all come from this formula. Okay. Now, what is the next step? We also learned some rules of derivatives or rules of differentiation. Rules of derivatives. For instance, if you have two functions and you add them, like f plus g, their derivative, I mean, the derivative of the sum is just the sum of derivatives. So f plus g prime is f prime plus g prime. This is also true for subtraction. So f plus minus g prime would be f prime plus minus g prime. So this is the sum. What about the product? So this is called the product, f times g, multiplication. So this is the addition, this is the multiplication. This is called product rule. Product rule. So fg prime is equal to f prime times g. So it's f prime times g plus f times g prime. So the derivative of the first one times the second function plus the derivative of the second function times the first function. Product. Then you have quotient. Quotient means division. When you divide two functions. Quotient. So f divided by g prime is equal to, again, f prime times g, but this time minus, there's the difference, f times g prime divided by the denominator g squared. And today we are going to add another rule, that is chain rule. This is the most important one. I will talk about it later. But I will discuss this later. Okay? Today we will talk about chain rule as well. What else we have learned so far? We also discussed the derivative of sine, cosine, and those things. Okay? So let me add a few more equations. So we learned that, for example, if f of x is sine x, then the derivative f prime, do you know what is the derivative of sine? Okay, so it's cosine of x. For cosine, the derivative would be minus sine. We also learned the derivative of tangent. F of x equal to tangent of x. Then f prime would be 1 plus tangent square of x. That is equal to secant square of x. This is just some identity. 1 plus tangent square is equal to secant square. So if I ask you what is the derivative of tangent, you can either say 1 plus tangent square or secant square. Derivative of cotangent is similar, except there is a minus sign here. So this is derivative of cotangent. I'm not writing, but you can, it is in the book. It's minus 1 plus cotangent square. Minus 1 plus 1. And lastly, we have the derivative of secant. So f of x equal to secant of x, then f prime of x is equal to, the derivative of secant is secant times tangent. Okay, so far you have this x to the power n, whose derivative is n times x to the power n minus 1, and you have this function, sine, cosine, tangent, secant. We are going to add to this, our list of functions, more functions like exponential function, logarithm, and so on. So we have to complete our list of functions. But before that, let me tell you about, we also discussed the relationship between tangent line and the derivative. So if you have a function and we look at the graph of a function like y equal to f of x, so this is the graph of a function y equal to f of x. Okay. Imagine that we have this xy. Cartesian plane. Now the question is, what is the equation of the tangent line at some point on the graph? For example, this is the point x equal to a. So y is f of a, of course. Okay, so the tangent line, maybe I can use it. So the tangent line is this line. This is the tangent line. Say L. L is the tangent line. So now the question is, what is the equation of the tangent line? And the answer is the following. First, so because in order to find it, write down the equation of a line, any line, you just need one point that belongs to the line, that is on the line, like this point, and the slope. So it's enough to find the slope, and the slope of the tangent line is given by the derivative of the original function at that point. So the slope of the tangent line is f prime of a. So the slope of the tangent line m is equal to f prime, the derivative of the function at that point, at x equal to a. This is the slope. And we have also, we know that this point a and, so the tangent line passes through this point, a and f and a. Now, once you have the slope and one point, the equation of the tangent line, equation of L, which is just this tangent line, is given by y minus f of a is equal to m times x minus a. Right? Okay. So that is the equation of the tangent line. So sometimes they ask you, here is the function, write or find the equation of the tangent line at such point. Okay. So for instance, look at this function, y equal to square root x. Write down, so first of all, draw the graph of this function and also draw the graph of this function and draw the tangent line at x equal to 1. So this is example. I want you to do this now, right now. So draw the graph of this function, y equal to square root x. Then find the equation of the tangent line and draw the tangent line at x equal to 1. So y equal to root x, y prime is 1 over 2 root x, right? We just discussed this. So what is the derivative at this point? So y prime at x equal to 1, y prime of 1 is 1/2, right? So this guy, this number is the slope of the line we are looking for. So the slope of the tangent line, this guy is the slope of tangent line. So this is the slope, m. So we have the slope. Now, what point I'm looking for? So x equal to a. If x equal to a, what is the y value? Sorry, x equal to 1. X equal to 1. X equal to 1. The y value would be equal to what? 1. This is the point 1 and 1. Because root 1 is 1. So now it is just grade 10. I mean, forget about the derivative and everything. What is the equation of a line with a slope 1/2 that passes through this point? What is it? What is the equation of such line? The slope is 1/2, so you have 1/2 times so y minus 1. I mean, this is a general formula. Also, always remember this. Y minus y0 is equal to m times x minus x0. Here, but when I say x0, y0, these are the one point on the line. So y minus 1 is equal to 1/2 slope times x minus 1. Okay? So the equation of the tangent line is y equal to 1/2 x minus 1/2 plus 1, which is what? 1/2 x plus minus what I have to add. Minus 1/2 here, you have minus 1 on the other side. Plus so 1/2 x plus 1/2 is this line. This line is y equal to 1/2 x plus 1/2. So this is a tangent line, and this is the original function, y equal to root x. Sometimes, is that clear? Stop me. If something is not clear, okay, just tell me. Any question, Kenny or Ryan? Are you still alive?
Everything's fine.
Okay. I'm happy to hear that. Okay, sometimes they can ask you such questions. For example, at what point or points you have horizontal tangent line? So what does horizontal mean to you? The slope is 0. Horizontal line, no slope, it's just 0. So if I ask you at what points there is horizontal tangent, that means at what point the slope is 0. That means at what point, but what is the slope with regards to the original function?
Let me see.
The slope of tangent.
It's 1/2.
No, I'm not talking about this. I mean, I'm talking generally. So the slope of tangent line is equal to the derivative.
Of the rate of f of x.
Derivative of that, of the function at that point. So you have to think at what point or points the derivative is 0. Okay. For instance, let me find an example from the book. Or maybe I just give you this example. Something can be interesting. So I give you two functions, and the question is, at what point or points there is horizontal and this is a question, and f of x is like x over x squared plus 1. That is the first function. And then this is part A. The second part is f of x is equal to sine x. So basically the question is, at what point the tangent is 0? So first of all, we have to compute the derivative anyway, right? Can you compute the derivative of f for each of them? So for this, the first one, you have to use the quotient rule. Remember the quotient rule? So the derivative of f is the derivative of the numerator times denominator minus derivative of the denominator times numerator divided by denominator squared. So what is the derivative of f, Ryan? Do you hear me, Ryan?
Yeah, I don't have it yet.
Okay. So let me just begin. So for part A, the first one, f prime is, let me just write it step by step. The derivative of the numerator times denominator minus the derivative of the denominator times numerator over denominator squared. Now, what is x prime? 1. So you have x squared plus 1. What is the derivative of x squared plus 1? 2x. So you have minus, and then you have x, 2x times x, 2x squared. That's just x squared plus 1 squared. So f prime is going to be, so you have x squared minus 2x, you have 1 minus x squared over x squared plus 1, the whole thing squared. This is f prime. Now the question is, when, at what x, f prime is 0? So you have to solve this equation.
-1.
So when this guy, whenever you have a fraction like this equal to 0, that means numerator must be 0. So that means 1 minus x squared must be 0. So x squared is 1. So x is, when x squared is 1, that means either x is 1 or x is -1. So there are 2 points for part A. There are only 2 points where we have horizontal tangent.
I have a question.
Huh?
Could x also be 0?
Pardon?
Could x also be 0?
What do you mean? X can
No.
be any number.
Huh?
What do you mean could x be
Oh,
0?
you know that f prime equals 1 minus x squared over x squared plus 1 squared?
Yeah. If x is 0, when
If
x is 0, f prime is just 1 over 1. F prime is 1.
Alright.
When x is 0, f prime is 0.
Oh, I see. I see.
But I'm not interested in that. I'm interested at the points where f prime is 0, not x 0. F prime is 0. So
Okay.
f prime is 0 if and only if x is either 1 or -1. Is that clear?
Yes.
By the way, what's your name? I forgot to ask.
Any.
Ellie?
No, that is E51.
Oh, Betty. And you? Cynthia. My name is Bobak. Nice to meet you. Okay. You do B part B.
What's sound?
Look at the graph of f, which is sine x. Let's draw the graph of f. That is sine x. So for sine, the sine looks like something. This is y equal to sine x. So at what point you have horizontal tangent? Pi half minus pi half. So this is pi half minus pi half. 3 pi half minus 3 pi half. 5 pi half minus 5 pi half. So these points that indicate the points horizontal I can draw the tangent actually. So you see at this point, you have horizontal tangent lines. Right, so for example, this is pi half. This is 3 pi half. That is 5 pi half. And these are all negative. Negative pi half, negative 2 pi half, negative 5 pi half. Okay, is it clear? Any question, Kenny?
No,
Now I want to discuss the chain rule. So what is it about? The chain rule is a rule for computing the derivative of composite function. So when you compose two functions, so you have learned about composite functions. So for example, let me give you some example. Imagine that f of x equal to x squared plus 1. G of x is equal to cosine. So we want to compose the function like FOG. FOG means f of g of x, right? So what is f of g of x? F of g of x, let me write it down step by step. F of x is x squared plus 1. So f of g of x is g of x squared plus 1. Right? But what is g? G is cosine. So this is just some recall from advanced functions. We can also do g of f, g of f. So we first apply f, then g. Here we first apply g, then f. So g of f is basically g of f, which is equal to g of x is cosine x. So g of f is cosine of f. Right? Here are f and g. So what is f now? F is x squared plus 1. So it's cosine of x squared plus 1. So now I give you another example. If f of x is square root of 2x plus 1 and g of x is 1 over x squared. So tell me what is f of g of x? What is f of g of x? So f of g is square root of 2 times g plus 1, which is equal to square root of 2 times g. G is 1 over x, so x squared. So it's 2 over x squared plus 1. And if you simplify this, you get square root of 2 plus x squared over x squared. Which is equal to, if you again simplify, you get 2 plus x squared. Square root of x squared is absolute value of x. Okay, now what is, for instance, what is g of x? So g of f of x would be, because g is 1 over x squared, so is 1 over f squared. Right? That is equal to, f is square root 2x plus 1, so it's 1 over square root of 2x plus 1, so square is 1 over 2x plus 1. Okay, now what is the chain rule? Chain rule is super important. And I mean, if you want to master it, it takes time, honestly. You have to practice a lot. Because it looks simple, but in practice, it might be a little bit sometimes tricky. So it says that the derivative of the composite function like f of g, the derivative of f of g is equal to f prime of g of x times g prime of x. It is also written in another form or format if I, instead of g of x, if I use, oh, by the way, there is also this, f of g of x. So if instead of g of x, I write u, so for example, f of u could be a function of x, like g of x, for example, square root of 2x plus. So the derivative of f of u, this is also very common format of chain rule, is equal to f prime of u times u prime. So this is called the chain rule for derivatives. So the derivative of f of g is f prime of g times g prime. Or in other words, the derivative of f of u is f prime of u times u prime. Now, as I said, it's very important to understand or to learn how to use this in practice. Because in practice, you just see a function, you don't see f and g. example, let me begin by some simple examples. So I want this, I have this function h of x equal to, for example, sine of x squared plus 5. So, and the question is, compute the derivative. What is h prime? So what is h prime of x? You see here, I mean, when you are doing this, if you are a beginner, it's good to say, okay, I have function, another function inside the sign. So it's like f of g. So here f is sine, g is x squared plus 5. Or you can say f is sine, u is x squared plus 5. So if you are a beginner, it's better to just write everything down. So you can say, okay, let u equal to x squared plus 5. Okay? Because here we need also u prime. If u is equal to x squared plus 5, what is u prime? What is
2x,
the derivative of x squared plus 5?
2x.
2x. So then h is equal to sine of u, right? So according to the chain rule, so chain rule says that h prime is the derivative of sine, I just write sine prime of u times u prime, right? Okay, now what is sine prime?
Cos.
Cosine. So it's
Cos
cosine
u.
u times u prime. Now you just write everything in terms of u, because u is x squared plus 5, u prime is 2x, so h prime is cosine of u, that is x squared plus 5 times u prime times 2x. So h prime is, at the end, we saw that, we can say that h prime is 2x cosine of x squared plus 5. Because it's a multiplication, right? Another example. So h of x is equal to, for example, the square root of three x minus 1. Again, it's a simple example. Because we are a beginner, we just, okay, say, let's do it slowly. So let u, here we can also choose, again, we can choose u be equal to 3x minus 1. If u is 3x minus 1, then u prime would be equal to 3. So h, if I want to write h in terms of u, it's just square root of u. remember f of u. What is f? F here is square root. So h prime is equal to, now, if f of x is a square root of x, what would be f prime? 1 over 1 over 2 times square root u, right? Then times u prime. This is basically a chain rule. This is f prime of u times u prime, which is basically equal to u prime over 2 times root u. And that is equal to, what is u prime? 3 over 2 times root 3x minus. Right? So we saw that h prime of x is 3 over 2 times root 3x minus. So now I give you an example for you, I mean like exercise. Do this one. So exercise. Exercise. 1. So for each of them, compute the derivative. So h of x is 1 over square root of x squared minus 1. 2. H of x is equal to sine square of x times x cubed, or let me just write this. Or just sine square of x. 3. H of x is equal to two times cos square of x times root x. Or h of x is equal to square root of tangent x plus 1 divided by and here is multiplication. Okay, do these exercises right now. Let me know if you have any questions. trig identities. Recall. I mean, it's not related to our discussion. It's not related to derivative. It's just grade 11 and advanced function and this thing. So sine of 2x is 2 times sine x cos x. Cos 2x is cos square x minus sine square x. And this is equal to 2 times cos square x minus 1. And it's equal to 1 minus 2 times sine square x.